Alright, so trapping rainwater. So the problem states that I'm given a few blocks of different heights, and it has some water collected within the bounds, right? By the bounds, I mean the blocks. So if there is no bound on the left half and the right half, then there is no water that can be collected there. But if we have two blocks separated and we have some space in between, then we can collect water, and we want to find the area of the water collected. So there might be several ways to solve this problem, but I'll tell you, a way that was intuitive to me, but in terms of implementation, it might not be so good. But since it was intuitive to me, it might be intuitive to you as well. All right, so let me just line this with the diagram. So these are the heights and these are the indexes. All right, at one point of block, if I reach there, if I'm iterating this vector of height and I reach this block, what would I want to, determine the amount of water this particular block is might be storing, right? So that can be defined by the other block that I will find eventually in future, isn't it? So if I have this block with height, suppose x, and I have another block with height, suppose y, and I have a couple of blocks as, suppose one block here, this is z, this is a smaller block. In that case, how much amount of water will this block be storing on its end? It's equivalent to the suppose this is at index a, b, c, d, e, right? So I would want the block next to this, which is having a greater height than this one, if it's possible, right? The next greater height that is possible, or next height which is greater than zero, and the maximum as well. So what I mean is, from this point, if I look here, I want a height which is greater than zero, of course, but in terms of the height, it should be maximum as well. So first I'll encounter z, okay, but then I'll encounter y, right? So this is the one I'm interested in, and this is the one which will decide how much water is going to be in between this and this. So how much water, if I'll calculate it, how much water will it be? It will be nothing but minimum, whichever height is minimum, that will be the height of this water. There's a block here, I'll take care of it. But right now, what can be the area of this portion? This will be nothing but minimum of x and y into e minus a, because this is the index, minus 1. Because I want the space in between, I don't want the space of x and y, that's why minus 1. So this, if I multiply, then this will give me the area, which is this one. Alright, cool. But this area will also be included in this. So that's a problem. So as soon as I encounter, suppose I have some way of, at this point, knowing that what is the next height that I'm interested in, that is y. Suppose I have that information. In that case, as I'm iterating, I'll see that I'll activate a mode or some form of information that I'll activate, which will mean that any block that I find in between A and E. So I have information at X-ray, what is the next building, that is Y, and I have this information which index it is in. So I have this information at this point. So between A and E, whatever height of block I will find, I will reduce, because this block of water won't be present. So I'll reduce it from this point. Suppose there are other blocks as well. So suppose this is S. So I'll remove S, I'll remove Z, and I'll keep on removing until I end up reaching E, and then I will deactivate that mode. Alright. This way I will get this area minus S, because S is the height and the width of every block is given as 1, and finally minus 0. This will be my water stored here. This is how we are going to solve this problem. Alright. So this is basically monotonic stack, because I will need this information, right? So for that, So this information will be for every block. So for S also there will be information. For Z also there will be the information for the next building. For Y also there will be the information for the next building, and so on and so forth. So that can be easily implemented using monotonic stack. So if eventually if I uh, clear this up, all right. So if I find this required information for each building, then I will iterate from this portion from the opposite side. I'll find that the stack currently is empty. I am here. I will see that the stack is empty. So for this position, there is no other building on the right that I'm interested in. So for this one, I will have -1, -1. This is the height and this is the index. So right now it's invalid because there's no such building that exists that I'm interested in. So I'll store this information for this value. So I'll have a vector of this size, and in that at the last position I'll store this, right? And I'll push it in the stack along with its index. I will go ahead with 2. I will check what is the information. Firstly, my information for this building, information of the next height of this building, and after this building, that will be initially -1, -1. I'll see that 1 and 11 is there, so I will update this with 1 comma 11, right? Sorry, this is 10. So 1 comma 11, I'll update it. It's not going to matter because the height is going to be 0, or the distance between them is going to be 0, but still I'll have to, update it, and then I will find that 1 is smaller. I want something greater, so I'll pop it, but eventually I'll see that there's nothing smaller. So this is going to be the information that I'm going to show for this building. I have popped this, so I'll push this 2 comma 10, and let me delete these things. So right now my that vector that I'm talking about in which I'll store the next building's information is nothing but -1, -1. For this building it's 1 comma 11. For this building it's going to be uh, so I'll add 1 comma 9 as my current building. I'll see that 2 is greater, so I'll update this vector as 2 comma 10, and I'll push this here. So this is 1 comma 9. Let me just delete this. I see 2 comma 8. 2 comma 8, I'll check the, initially it's -1, -1 for this one. 1 comma 9, I'll update 1 comma 9 for this one. I'll push it here, but before pushing I'll have to pop this. uh, I'll pop this. I will still add this, even though it's same height. I will still add this. I won't pop this one. uh, Actually I can pop this. uh, this is the current building. I have updated 1 comma 9 and I have popped it. uh, I see 2 comma 10. I should update this with 2 comma 10 instead of just comma 9, because right now the top is 2 comma 10. So I'll update it with 2 comma 10. I will pop this now. I will pop this. I will add 2 comma 10. Finally I will check for this one, 3 comma 7. This is greater. I want the greater one to be at the bottom, so I'll have to pop things. But for before popping, I'll update 2 comma 10 with the maximum height of the next building, and this will be popped. This is already popped. So right now my this will be 3 comma 7. So finally I'll keep on doing this, and eventually I'll fill the next heights information for each building and or block, and then I will iterate. and I will activate and deactivate and do the stuff that I've already explained. So let's get into the code. So for that, I'll have a stack. I get vector. This will store two information. So I have a vector of int. I'll call it st. I will traverse from the opposite direction. So let me have a int n is equal to height dot size. All right, n I is greater than or equal to 0. Sorry, this will be n minus 1 and I plus plus. I will have a vector in which I'll store the information that I was just showing. So this I'll call next max height probably, or next height is also fine since it's not max all the time. I can have something like this. This is 4, this is just 2, and this is 3. So at this point, there is no maximum, next maximum, right? There's 3. So I'll have 3 and its index, that is 2, stored here. So it's not next maximum height, it's just next height, as we'll call it. And its size is going to be n. Initially, or actually, I also need the indexing, so I'll have a vector of vector. Initially, I'll initialize it with -1 for all. Alright. So now I'm iterating, I will be here. I will check if the stack is empty. So if it is empty, then I'll push it. Otherwise, I will check if have a vector of pair which will initially be -1, next greater, -1. Alright. And I'll check if stack is empty and if stack is not empty and the stack top of 0, which is the height, is greater than the next greater, or no, actually the height of I at this point, right? Since I want the next height to be greater at the top, right? If it is not, I'll pop it. So if the top height is smaller than height of I, which I am currently at, in that case I'll do st.pop. Before that, I will still update the next greater with whatever value I encounter if it's greater. So if next greater of 0 is greater or smaller than st.top of 0, which I'm going to pop in the next moment. If it is, then I will update greater of 0, or actually with both the index and the height, that will be st.top. So at this point, if the stack is not empty, then and this is still true, in that case I will do the same thing here as well. I'm doing this again, you must be wondering, because this is being done again because I might have some I have something like 4 and this is 5. I had something like 3 in between. So if I'm here, my stack is going to have 5, and then it's going to have 3, and then it's going to have a 4. So for 4, I'll pop 3 and I'll update the height, the next height for 4 as 3, but I won't pop 5, right? So eventually I should have updated, eventually I would not update 4, 4's next height with 5. Right now it's 3. So that's why I'm doing it again to, if it is not empty, then I'll have to update it with the top of whatever the stack is having. Actually, I don't even need this. I don't think so. So whatever the stack top is having, it's definitely going to be larger. That's why I have not popped it, right? Because that's this this condition and the condition that I had cannot be, going together. It's just opposite. So finally, I'll push with what? With the next greater element, actually. Oh no, my bad. I should push the current height and its index. Right. So, okay. At this point, I should update the next height width of I with next gate. So finally, now for each building, I will have the information that I want. So now I have to have something like, so I have to take care of the ones in the middle, right? So for this one, I will, so this is 3, this is, sorry, this is 2, and this is 3. So I'll have what? This is, suppose the distance between them is 1, 2, 3. So 3 into the minimum of the 2, that is 2. 6 area of water is in between, but that's not true, right? So I'll activate something here, and I'll keep on doing the negative of these two blocks area from this one. Eventually, when I reach this point, I will deactivate that mode. So for that, I will have something like no snow mode. I will initialize it with false, and end activation. This will contain the index. Initially, it's -1. So at this point, I will deactivate the mode back. So finally, I will iterate through the next heights or whatever I have made. That is this one. If if the next height, so let me do the other things. So if the no snow mode is activated already, this means that my end activation must not be -1, right? Because my no snow mode is activated, so it must be some value. So if I is equal to that some value that end activation is having, if it's equal, then I will deactivate the snow mode back, and uh, I will make the end activation as also -1. Otherwise, I am somewhere in the middle, like here, here, here. So I will subtract the height of whatever blocks that I encounter. If the snow mode is not activated, then I'll have something called answer, which is initially 0, and I will update the answer with what? Will be updated with the distance. What is the distance? Distance is nothing but absolute value of, I'm taking absolute, I don't need that, but just for making things simpler, absolute value of this end activation minus I -1. So this is the distance, and uh, whatever height, minimum of the current height that I am at right now. So if I'm here, if this is minimum, or the next height which I have stored in this one for the next height, that is 3. If that is minimum, whatever is minimum, I will use that. So the next heights, first element will be the height. So whatever will be the minimum, that will be my uh, height. That is that is going to be the height of the water as well in the middle. So this is what it is. And at this point, I should activate my no snow mode to true, and my end activation to false. Sorry, not false, -1. Sorry, not even -1. Uh, the next height's second element, because that will be the last index that I'm interested in. But I think, let's see where it fails. It'll fail at one point. We'll correct that. elephant, next crater, next height is this. Uh, mm, next height of I is equal to next crater. There's something wrong here. Let's see what it is. Next crater is implemented here. Next crater. There's a vector frame which is fine. Uh, is it outside? No, it is inside. It is within. It is accessible. Uh, oh, my bad. This should be being backwards instead of forward. And this huge mistake somewhere. So the problem is, how can I explain? Uh, at this point, I won't be going in all any other direction, right? So suppose I'm here. Suppose I'm here. So I've reached the end activation, right? This will be the end activation for this building. So at this point, I should take the consideration for this one as well. For this block as well, I should activate it back for the next height, right? So that's why I should not go back and do I plus plus here, but instead I should remove I plus plus here and do it in certain places only. Like this is the place where I should do increment, and this is the place where I should do increment. In any other place, I shouldn't do any increment. And in scenarios where I find that the next height is a -1, in that case, I shouldn't do anything, right? I should just remove, just break out from there itself. So in that case, I can have a check if this is indeed -1. I can just do a continue. Mind that I should increment here as well, otherwise it'll be time limit exceed. Let's see if this works now. It doesn't, and it goes really far. Alright, so the problem here is that, by the way, this will be I plus plus. The problem here is that instead of end activation, I shouldn't do the end activation here because end activation has not been initialized yet. But I should take the second element of next height. That should be the right index, the end index that I'm interested in. And here, when I'm trying to find the next height, I don't need. I don't need to do anything for processing for the ones which have height as 0, isn't it? So I can just continue rather, and this is it. This should work. Let's see. Yeah, it does. So this was a mistake, and let's try to submit it. This is a monotonic stack approach. Probably there might be something simpler as well, but this was intuitive to me, and I believe since we are doing the stack finding, the next height, that will be a O of n operation, and this will also be a O of n operation since we are iterating it. By the end, I believe it should be O of n and O of n in terms of time and space. Even though it shows it's not so efficient, it is what it is. And I hope this was intuitive for you. Thanks, guys.